Okay, so think beyond those classic sci-fi movie things for a second. Forget the simple radar blip you might see. We're talking about a technology that's, well, it's quietly revolutionizing our world.
In a really profound way. It's about seeing things in 3 dimensions.
Exactly. And that's what this deep dive is all about. Our mission here is always to cut through the noise, grab those essential nuggets of info from all the complex stuff out there.
And give you that shortcut, basically. Make you the informed person in the room.
Precisely. So today we are jumping into the world of 3D radar. And like we said, it's way beyond just military uses now.
Oh, absolutely. Though defense is still a massive driver, obviously.
Right. But this tech gives you super precise three-dimensional tracking, so range, elevation, and azimuth. It's just a whole different league compared to traditional 2D radar.
It really is. And what's fascinating, what's really lighting a fire under this market, is this blend of things happening all at once.
Yeah.
You've got growing security worries globally,
Yep, see that everywhere.
increasing military budgets, and then there's the integration of really cutting-edge tech. Think AI, machine learning.
Ah, okay. So AI and ML aren't just like tweaking the old systems.
No, it's much more fundamental. These systems can now learn, they can learn to tell the difference between, say, a flock of geese and an incoming drone,
Hmm.
or predict a missile's path with accuracy that was, well, frankly, impossible before.
Wow. That changes everything for situational awareness.
Exactly. It's intelligence baked right in.
Okay, let's dig into that a bit. So, 3D radar. What's the absolute core function and why this boom now? It's that extra precision, right?
Yeah.
But what does that mean day to day?
That's the key. 3D systems are just way more precise than 2D because they add elevation.
The how high part.
Exactly. It's not just is it out there. It's where is it horizontally and vertically, that complete picture.
For air traffic control must be huge.
Revolutionary.
Yeah.
Honestly. Safer skies because controllers see everything in 3D in real time. You can manage airspace much more tightly. And for defense, well, superior target tracking, surveillance, navigation is critical.
Makes sense. So who's actually using this? What's driving the demand?
Well, according to cognitive market research, the drivers are pretty diverse. It's not just one thing. You've got huge demand from automotive.
Self-driving cars, I bet.
Definitely.
Yeah.
Big time. Then public infrastructure, think smart cities, energy and utilities monitoring their grids or pipelines, and of course, government and defense sectors.
That's a really widespread. Okay,
Yeah.
so give us the numbers. How big are we talking market-wise, and where's it headed?
All right, so the estimate for 2024 puts the market at around 17.5 billion US dollars, roughly.
Okay, decent size.
But here's the kicker, the projection. It's expected to jump to something like $47.2 billion by 2032.
Whoa, seriously.
Yep, that's a compound annual growth rate, a CAGR, of about 13.2% over that period.
13%, that is. That's explosive growth. Are we seeing this play out in, like, actual new products hitting the market?
We are. Look at Toshiba, for instance. At Eurosatori 2024, they were highlighting stuff specifically for coastal monitoring and drone security.
Okay, like what?
Well, they talked about using GaN amplifiers in a 3D coastal radar.
Hmm.
GaN is gallium nitride.
Right, the semiconductor tech, more efficient.
Much more. More power, less energy, smaller package. So you get these really powerful radars, but they can be lighter, more mobile, perfect for drone defense. They also showed off lightweight modules and a full counter-drone system, a CUAS, using radar and cameras together.
So real-world applications right now.
Exactly. It shows the innovation isn't just theoretical.
And you mentioned drones, UAVs. Defense forces buying more of those seems like another big piece of this puzzle, right? Equipping them with 3D radar.
Absolutely. The more drones are used, especially sophisticated military ones, the more they need that advanced 3D radar for spotting tanks, helicopters, other aircraft, you name it.
It's like a perfect match. The platform needs the eyes.
Precisely. It's a symbiotic relationship, really pushing the market forward.
Okay, so we get the what's and the why. Let's talk where. Where's the geographic center of gravity for this? Who's leading?
Well, in 2023, North America had the biggest slice of the pie, about 35%.
And what's driving that primarily?
A lot of it is investment in weather monitoring,
Hmm.
tracking storms, trying to get ahead of catastrophic events, which seem to be increasing.
Makes sense given climate change concerns. What about Europe?
Europe's not far behind, around 30% market share. There, it seems to be a mix. Government's putting money into advanced surveillance systems, reconnaissance frameworks.
Defense and intelligence again.
Right. But also, significantly, getting approvals for advanced radar systems in cars. So defense and automotive playing big roles there.
Interesting dual focus. But I hear Asia Pacific is the one really taking off.
That's right. Asia Pacific is the fastest growing region. Started around 25%, expected to hit maybe 28% share by this year, 2024. It's got the highest CAGR, around 11%.
Wow. Why such rapid growth there?
Well, countries like China and India are investing heavily. Plus, unfortunately, you have regional tensions, conflicts, nuclear powers.
Yep.
It makes advanced 3D radar deployment feel, well, necessary for national security.
A security imperative driving adoption. Got it. So this booming global market, it must be pretty competitive. Who are the main players?
Oh, intensely competitive. You've got several major players dominating. In 2023, Airbus Defense and Space had roughly 25% share. BAE Systems was around 19%, and Harris Corporation about 15%.
So those three hold, what, nearly 60%?
Pretty much. They're the big hitters.
That concentration suggests their R&D is really going to shape where this tech goes globally.
Absolutely. And their investments dictate the pace of innovation, how quickly new applications pop up.
Who else is significant in this space?
You also have major players like Raytheon Technologies, Northrop Grumman, Thales Group, Leonardo. They're all heavily focused on R&D, pushing the envelope for aviation, defense surveillance systems.
How do they all stay ahead? It sounds like a tough race.
It is. It's constant R&D investment, but also smart strategy. Mergers, acquisitions, partnerships, anything to broaden their product range and extend their global reach. It's an innovation arms race, basically.
Is it only the giants, or are smaller companies finding space too?
No, definitely not just the giants. You have startups, more specialized companies making real contributions, especially when it comes to leveraging AI and machine learning to boost radar performance. They can be more agile sometimes.
So fresh blood coming in.
Yeah, and we expect to see more new entrants, especially in those booming Asian markets, probably by this year or next. The projection is actually that the combined share of those key players might nudge up slightly, maybe to 42% by 2025, mostly because of the demand in high-precision aerospace and defense.
Okay, so market's hot, tech's advancing, lots of players, but surely there are roadblocks. What challenges could potentially slow this whole thing down?
Definitely challenges. A big one is just the cost. The upfront investment needed for R&D, manufacturing, even just marketing and explaining the tech to customers. It's significant.
Right, it's complex stuff, not cheap to make or sell.
Exactly. And that high barrier to entry can make it tough for, say, a promising startup, even with great tech,
Yeah.
especially in developing countries. Plus, more competition is actually putting some downward pressure on prices, which sounds good, but it can squeeze margins.
Okay, cost is one thing. What else?
Regulations. The regulatory landscape is tricky.
How so?
You've got layers of national and international rules, especially for defense and aviation uses. Getting a new system certified, making sure it complies everywhere, it takes a lot of time and money. Imagine navigating that in 10, 20 different countries.
A bureaucratic maze. Okay, and what about the people needed to run this tech?
That's another bottleneck. There's a real shortage of skilled workers, people who can actually operate, maintain, and repair these complex systems.
The expertise gap.
Exactly. You need specialized training. And that gap can really slow things down, again, particularly in developing nations that might be trying to adopt the technology.
So you might have the budget, but not the trained personnel.
It's a real issue. And then there are just the technical challenges of the environments themselves.
Meaning?
Well, these systems often need to work in really harsh conditions. Extreme heat, cold, heavy rain, maybe cluttered urban environments.
Stuff that interferes with the signals.
Precisely. That can impact performance, reduce range, or accuracy. So their usability might be limited in certain very specific, very challenging locations.
Okay, challenges acknowledged. But let's shift focus. Let's look ahead. What's on the horizon? What exciting future developments should we be watching for in 3D radar?
Well, looking forward, one interesting trend is more international collaboration. You see examples like Indra, the Spanish defense company, partnering with IDG Group in the UAE.
What's their goal?
They're planning to bring military-grade radars to markets outside the usual European NATO sphere, places they call untapped and fragmented, so broadening the global reach.
Expanding the map makes sense. What about the tech itself? Any fundamental shifts in how radars are being built?
Yeah, a big one is the move towards solid-state radar systems.
Okay, what's the benefit there?
Much greater reliability. Less maintenance needed compared to the older systems with more moving parts. That makes them way better suited for deployment in all sorts of environments, military or civilian. It's a big step up in terms of just keeping them running efficiently.
Durability and efficiency. Got it. Now, here's where I think it gets really exciting mixing this with other tech, like IoT, 5G.
Oh, absolutely. That convergence is key to the future. Imagine Internet of Things devices, super fast 5G networks, and 3D radar all working together seamlessly.
What does that enable?
Much better device collaboration, massive data sharing. Think truly smart cities where vehicles, traffic lights, infrastructure are all communicating, all mapped in 3D space by radar. Hugely efficient traffic management, for starters.
Hyper-connected cities, wow.
It's the kind of infrastructure that enables that vision.
And will the rules keep up, the regulations we talked about?
They'll have to evolve. Expect regulatory bodies to set new standards,
Yeah.
probably focused on enhancing safety and efficiency even further. And that, in turn, usually spurs more innovation as companies race to meet or exceed those new benchmarks. It pushes the whole field forward.
Okay, last thing on the future then. Where else might this tech show up beyond the obvious defense, cars, air traffic? Any surprising applications?
We're starting to see potential in areas like environmental monitoring, using it to track very subtle ground movements, maybe atmospheric phenomena in new ways, and even potentially public health, maybe monitoring crowd density or flows, perhaps even remote vital sign detection in certain scenarios.
Public health. That's fascinating. Really shows the versatility.
It does. It pushes radar way beyond its traditional boundaries into areas we're probably just starting to imagine.
So wrapping this deep dive up, it
Yeah.
feels like we're on the cusp of something major. You've got this rapid tech progress, solid state, AI, ML, linking up with 5G and IoT. It's boosting accuracy, reliability, awareness across so many fields.
It really is a foundational shift, not just small improvements. 3D radar is becoming absolutely crucial for safety, security, even monitoring our planet.
Yeah. And those challenges, cost, regulations, skills gap, they're real, but maybe not insurmountable.
Hopefully not. But tackling them will definitely require serious cooperation. Governments, the companies making the tech, research institutions, they all need to work together.
A complex road, but the potential payoff seems huge. Which leaves us with a final thought for you, the listener, to chew on. As this incredibly precise 3D radar tech spreads everywhere, from our cities to maybe even monitoring our environment or health, how is that going to fundamentally change our daily lives, our whole perception of the world? Maybe in ways we can't even predict yet? What's the one totally new application you think might pop up first?